Well, good Saturday morning to everybody out there. I'm going to attempt to balance this crank for Pete out there in Texas, and I'm going to give you some backstory and some information, just general balancing information. So there's the balancing machine. And when I say balancing machine, what we're talking about is the two stanchions, the encoder, the motor, and all the wires. The laptop has the software in it, and obviously this is a Bridgeport. That didn't come with the balancing machine, but this is a mill mount Turner Technologies balancer. And I love it. It's great. It takes up a small footprint. Someday I'd like to get me like a drill press and maybe just leave it permanently mounted somewhere. But this is easy to take up. It's easy to put down when I need to mill. It's really easy to use. I've been using it for 5 years now, and it cost about $10,000 back then. And I think I'm probably at the break-even point where it's paid for itself at balance jobs anywhere between $300 and $600, depending on what happens with them. So probably say mean average for $450. So okay, all that's out of the way. Here's the information. You can see I've got it labeled. We've selected the engine, stock engines. I don't ever use the external. We just do it all in the same one. So we're going to tell it okay. Reciprocating weight 36.6. If you want to use 50, you put 50. If you want to use 41 something, 42 something, you can use that. Rod big end, rod total. It calculates all that. Okay. I use the average. Disclaimer: this is a stock rotating assembly. It's stock rods, stock pistons. This is a really nice crank. It's been machined. It's 10 on the mains, 30 on the rods. It probably would make a lot of horsepower, live a long time, but people paying big bucks for 109s don't really want 30 on the rods. So we've repurposed it into a mild build that'll probably last this guy forever, as long as he doesn't abuse it. All right, so then we have our rod bearing weight, our piston weight, same thing, stock piston, stock pins. I use the average on these. Don't have any pin locks as depressed. Rings, don't have any rail supports, and the oil weight is at 2. Okay, so that's your Bob weight card, and I save it under the name, and I can pull that up forever and ever as long as it's in my computer and it doesn't crash. All right, so now we're set up. Okay, and I've spun it a bunch of times. Well, this crank, I don't know where it came from. It came to me to get turned, and then when it went to 30, the customer didn't want to use it, so it was gifted to me to offset the machining cost. So here's where we started with the stock balancer and the stock flywheel. Way too much. So I messed around with it, and right about here is where I put on a neutral balance stock type flywheel. This is the ones that Richard Clark taught me to do years ago. See the half moons? The half moons are gone. You just take a hole saw, you drill them out. It's pretty close to neutral. This is a stock flex plate. That's all it is, modified. I believe some builders like Weber and them did that as well. But I'll just say Richard Clark style because he's the one that taught me. So enter Richard Clark style flex plate. That's a pretty good difference. That's still a lot of material. I'm not messing with the front yet. I still have the stock balancer with the big weight on it. So then I took and put the Chinese gold scat version on there, which is a nice plate. And then it got me down to 117 grams. So here I removed the stock balancer and put on a neutral balance TA balancer. All of a sudden, things are good. So what we learned to this point is this was an internal balance crank. We're not surprised. It's got heavy metal in it. It's got welding on it. And it's been drilled. As you can see where my marks are, we've already started to remove material. So in the interest of time, we're down to spin 21. Here's where I am Saturday morning. There's where I was Friday night when I quit. Very little change. So 28.4 grams is left on the back. 36.1 grams is left on the front. Factory tolerance is 20 to 30 grams. I'm going to get it at least as good as factory tolerance since it's just a stock rebuild. Maybe if I'd love to get it down to the performance spec, but I don't want to Swiss cheese the crank. So here you go. This is what happens when you rework a crank that's had another rotating assembly on it. But when it's done, it's going to run. The engine's not going to know that. And in my opinion, for what this engine is going to be used for, this is not going to be a downfall at all. Or I wouldn't do it.